So let's get started. So today, just wanted to spend some time reversing some stuff for fun. And of course, this is one that was brought up by Malware Hunter team, as usual, sharing stuff that's potentially interesting. So this one is called Installation Instructions, the Mako, and it had one detection at the time of this sharing, and some additional context here. Looks like this is a C2, and we then have a reference to what this may be related to back in December. So these are always fun to kind of dig into. You may find something super interesting. So I usually just pay attention to what they're sharing and spend some time on them. All right, so I spent some time on this yesterday, a good amount of time, but I still think it's a fun one to go through because I think it's really cool to watch someone kind of go through their reversing and see how they do it. And I learned a lot from that. So hopefully this will help others. So just go into the main function here. And on the right, we'll see I already wrote up a script yesterday for this to help with the decoding. And it's pretty simple. The only thing that kind of caught me off guard was the use of the wide characters. So ASCII bytes are separated with 4 bytes, so there's like null in between them. We'll see that in just a moment. And yeah, so this just does a simple XOR. And three things that I pass to this function are the address, the count, and the XOR value because they're different for each one of these functions. Each one of these functions returns a string, and that's what all these like weird function names are in here. So there's probably a better way of automating this. I have not figured that out. So let's just get started. I'm in main, and the first thing here we see is a call to strlen to get the length of the string that's passed in as an argument, and that is going to be the return of this function. So we see this here, here, and here. So this is going to return a string. We see other string related functions here like stir copy. So let's get started in there. Double click in there. So we see a mem copy really quickly. This is the source, which binary just sees as like this wide string with this prefix u here. And if we go in here, we'll see these ASCII characters separated by null bytes. So that tells us this W char here. And yeah, so it's moving whatever is in here with this mem copy into the destination, which then this destination is used down here, as we can see inside of this for loop. This for loop, for those that have seen this a lot with XORing, which is used very commonly on malware, we have this XOR, and we are then iterating the bytes one by one in this for loop that is 0x23, which is 23. So it's 35 bytes, and it's going to return that string to the function, the strlen function. So all we need to do is plug and play here. We need to get the address of this source. So for that, we go to the disassembly. We see this load effective address to RSI, which will be the second argument passed into this memcopy function. The first will be the destination. So this is the destination of the string. We're going to grab this address. There's going to be a lot of copy pasting, but that's fine. We know the length is going to be 23. That is the bytes that are allocated, or the space allocated with the malloc. And the XOR key will be this 2F, which I believe is a / in ASCII. So save, run, is going to return this string. So this might look super ugly, but in my head, it makes sense. So I'm going to edit this function name so I can show what it returns. And I'm just going to put this in quotes, just like that. Accept. Now we know this is going to return this library application support. path. Okay, so that's going to return that, which then is passed into the stir len. So this is like len of app support. And then we have a malloc that is going to return some allocated space here using this length plus the length of whatever this returns. So let's go in here. So same thing, mem copy. This gives us a pointer to those strings that are going to be decoded. And then this is going to be of length 19 or hex 19, and it's going to have this key. So let's just place this 19, and there's probably a much better way of doing this, but it's all right. So installation instructions, which we recall, that's the name of this binary. So that's interesting. So let's do that here. Same like we did before. Might look ugly, but in my head, it kind of makes sense. Okay, so now we're going to add both of those together, and it's going to allocate some space. So allocated mem, yeah, let's call it that. If this is 0, which that would not happen with this malloc, because malloc is going to return a pointer to this allocated space, then it exits. So next, what it does is a stir copy. So it's going to copy this string, which we can see here, which is why I renamed it so I can remember what it is. And it's going to put it into this allocated space. Then it does a stir cat using this string into that allocated space. So remember, this is modified by this stir copy, and then that same pointer is used to append to it. And the way that we know that, all right, so man, stir cat. So concatenate strings. We have 2 arguments, s1, s2. So appends a copy of the null terminated string s2 to the end of the null terminated string s1. So it just moves this and appends it here. So now we know that this allocated memory is going to be the combination of these two. So let's just say path to inst, which is what I'm just going to name it that. That gets passed into this function. So now we need to know what this does. So let's grab this. We know that this is that path instance. I like changing this argument quickly so I don't forget what it is. And then we're doing this getEnv call. So getEnv is going to return the environmental variable of whatever string is passed in. So if you want to verify that, just come in here, and then we're passing in this name. So we know this function is going to return another string, as we talked about. And then it's going to return the value of the environmental variable as a null terminated string. If it's not in the current environment, null is returned. So there's probably a check for that. Yeah, right here. So check for that to see whatever is returned from this. So we need to know what string this returns. Come in here. We don't see the address. This is Binary Ninja trying to make sense of what the string is. We can see the null bytes in between these. So let's drag this over. Look at this assembly, because most of the time it's prettier. And let's just copy that address. And the length of this, I believe, is 4. And FF is the key. FF. Save. Run. Home. Okay, so the string home is returned. So this is going to be passed to, this is going to return home as a string, and it's going to be passed to the getEnv function. Let's go back. So this is then going to return like the user's home directory. User home. Okay, so now we have this malloc. We're getting this path, this long path that we passed into this function, getting the length of that. And then we're adding the length of this user home, and we're adding the length of this string to create this, what binary ninja called big, this allocated memory here. So for the next string, we need to figure out what this is. So this is binary ninja, try to make sense of it again. So we got to kind of go over and look at that first address. So let's grab that and let's replace, what's the size, 6 and 5 4. Say run home. Okay, so that's interesting. It was weird that that first one had that home string there like this. But having looked at this before, that's going to be used to search for that and do a replacement, which we'll talk about. So we have all this being allocated, and we're then doing the path. So this path that we passed in, which remember contains home in the squiggly brackets, we are then moving that into this allocated space. And then we're doing a stir. So that's one of those like searching functions. So stir. So locate a substring in a string. We pass in a haystack, which is what we're going to use to search, like what we're searching in. And then we're passing the needle, which is the actual value inside of that we're looking for. What does this return again? The stir function locates the first occurrence of the null terminated string needle in the null terminated string haystack. So it returns the first occurrence of the null terminated string. Okay. So stir, it's looking for this home inside of this allocated space. And it's going to return that. So I'm just going to name that found. If found, we have this stir copy that is the user home is put into this pointer to replace it, and stir cat is then used to concatenate this with the path to inst. So this is going to replace the home in those brackets with the actual home of the user, and that returns path with home. Cool. So let's see what this is used for. Path with home is returned, so path with home. And now big is used here with arg2. Okay, so arg2 in this case, right? So this C here, so we have argc, so the count of arguments, and then we have argv, an array of arguments passed in. So this that array, the first element inside of that array is going to be the binary itself. So when we're getting that value and putting it here, this is going to be this binary that's executing. So path to binary. Path with home, it's looking for this inside of the path to binary. And it's found here. If it's not 0, right? Found, and then this will be equal to 1. So it's setting this value to that. And then if not there, if this there, then it's going to do all of this, because this should return that. Yeah, okay. So let's see what happens at the end of this if. Okay, So if they match, then we continue down here. If not, all this other stuff happens starting from this if. So let's see what happens. This mem set happens for this length. It's just putting zeros in this location. And then it's doing a stat here. So stat will check if a file exists. Hold on. Man, 3, 2. Okay. So get file status. It's going to check to see if it exists. If it does not exist, it will return a -1. So this path with home, which is this installation instructions directory inside of application support, will then be created if it does not exist. So create path to inst folder. Okay, so now we're doing another strlen, and we're getting that length of application support. And then we're doing another one of those. So let's go len of app sup again. That's fine. And then another length of, so this is the length of app sup 1. Just setting that again. So let's put it to that. And then we're doing a malloc with, oh yeah, so this was adding that. So malloc for this, so allocated mem. And now if that fails, we exit. Now we're doing a stir copy, this allocated space with the length of both of these put together with whatever is returned by this function. So let's go in here. Same thing. So we're just gonna copy paste some values, go over, find the address of this, first reference to this address. Where those bytes are is here, so let me put this down. And then let's overwrite this. Oh, didn't do it. So copy, paste, and then what is the length of this? Don't remember. 4. 4, and then the XOR value is A5. Let's see what this returns. Com dot. So that's like that reverse domain notation that's common on macOS and iOS stuff. So this is going to be used at some point. It's com dot. So let's go back. This returns that com dot, and then we're concatenating this installation instruction. So let me just grab this. This is going to change what this is. So we'll do com dot, and we're concatenating this string. So this turns into this. I know it looks ugly, but it's okay. Okay, so path with home, we're getting the length to that. So length of path with home. And then we're mallocing that. So allocated mem with the installation instructions and the length of that. And then we're running whatever this function is. So let's go in here. Another one of these. So let's grab this. And then what is the size of this? I think it's 5. And then the XOR key was up here. XOR key is 20. Hex 20. So 32. All right. So we have format strings now. So these will be replaced at some point. So let's grab that. Replace that. Go back. Figure out where we are in this mess. right here. So this returns that. Oh, don't need to do that. I pressed M by accident for an enum. And this is going to then be %s /%s, except this is set to null right now, so null. And then we're doing a huge s printf for this allocated space, replacing this format string with the path with home, and then the com dot, the installation instructions, and then the com dot. So this is going to be the entire thing here. So this is going to be full path. Okay, so path to binary, which was argv, argv0, which is the path to the binary that's executing, is passed in with this full path that was just created with this fprint f function. This is looking for, this looks like a Boolean because it's checking against 0 here. So let's see what this is. So let me just remember path to binary and full path. Okay. Path to binary and then full path. Okay, so first thing that happens is we're doing this fopen. So we're opening the path to binary and we're passing in the mode. So even the mode for these calls is encoded. So this is probably going to return like a single character or 2 characters. We can do this really quickly. I'm assuming it's a read, so it probably returns like, or a W, I don't know, we'll see. So this, and then it's just the value of 2. And what is that XOR string? Hold on, where was I with the Y? It was here. Okay, value of 2, and then the XOR string is A7. A7. Okay, so then save, run, RB. Okay, read bytes. Let me just, I don't have to copy that over. Read bytes. That is the mode that is used with this fopen, which returns a pointer to this file pointer to the path to binary, which we're passing in. If stream is not 0, which means if it's successful, we do another fopen of the full path with this mode. So there's another mode. So let's grab the address here. This is another 2. And then 1C. 1C. Say run WB. Okay, WB. So let's go back. So write bytes. Full path, which was passed in, which was this created path. Getting the stream with the write bytes. So if stream actually returned, like if this returned a file pointer, we're then going to fread the stream. So let's replace this to make sense of it. So this would be the read path to binary, and then this stream is write path write to full path. Let me just make sure I'm not confusing myself. And now we're doing an fread using this string that then will move whatever is read from the binary itself is then passed into this pointer. All right, so that should be that way. And So stream, and we put it here. Reads the objects is from the stream pointed to by stream, so it reads here and stores them here. So it moves that way. Okay. So this is going to be read bytes of binary. And now, after this, it just makes sure that that worked properly. Now we're doing an F write, and I think that moves in the other direction. We have these read bytes of binary, write to full path. So write should move in the other direction. F write reads from the stream. Hold on, no, write. We need the right one. Writes each size bytes long to the stream pointed to by stream. So it writes from here to here. So it moves the other way. Okay. So now we're getting this F writes. We're getting all the bytes, right, from this, and we're moving it here. So what this is doing is pretty cool. See it like this. It's copying itself to this directory because F write, F open will create it if it doesn't exist. Okay, so this then returns a value if this is successful. So this is, let's just rename this success. If it's successful, it returns 0. If not, it returns -1. So that's why there's a check for this. So this is actually, if we want to get technical here, this is a bool. This returns a bool. And let's go back. So if that was successful, it returns 0. So it copied itself over. Let me move this out of the way. And it then does a chmod to get some, so that octal, I forgot what that is, but that's like 0755 or something. So it does a chmod, so permissions, perms, and then it passes this com.installation instructions and the full path. Both of these are then passed to this function, which then is passed into this function. So if it was successful, do this. If not, return 0. If not, we return from here. So this is where we want to be. So we're going here. So this is going to be the com.installation instructions is the first argument. And then this, I forgot what it was, full path. So let's change these arguments so I don't forget. Okay, so we have this function, we're passing in this other thing, and it looks like we're doing another huge sprintf to do something. So there's another check to see if something exists. If not, create it, and that's going to be this. So this is going to return a path. So let's see what this is. We have the address here. So let's overwrite this. And then that's going to be, well, this is a pretty large string here. So that's cool. And then 29. Run. Finally, reference to launch agents. Oh, it's probably going to do the same thing. Where it's going to then replace this home with the actual home. Interesting that they did it that way. Very space cautious, which is interesting. Okay, so that's going to return that. So let's go back to where this is called. This is called here. This returns this to this function, which then does what we've seen before, which I should have renamed this. So this should be renamed to replace home. And then we're going to replace home with the actual home because we already looked at this. I knew that this one looked familiar. Replace home. So this is path to launch agent. is what's returned there. Okay, so then there's a check for it, so that this is -1. Path to launch agents. So if it does not exist, then you make it so by default on macOS, this directory is not it's not created. So usually there's checks to see, if someone wants to put something in there, even a legit app, they'll check to see if it exists, and if it does not exist, they create it. So very similar. Path to launch agents, the length of this is moved here. Path to launch agents, oh, hold on. Len of. Okay, and now we're getting that length, and then we're doing a malloc using this return. So this is going to be the we're adding the stir length of com.installation instructions. So length of persist. And then we're getting the stir length of this. And this is another one here, 6 bytes long. So let's just go through this quickly. I'm not sure how long we've been going now. So let's just replace this and try to make it nice and easy. So this is 6. And then 7E. 7E. Save. Run. Finally, reference to a .plist. So this will then be appended to that in order to create this persistent item. So that is returned there. So this is going to be allocated, which I usually just change these after the fact. Then we're dealing with this function, which does other stuff. So let's grab address, and then 7 is the length, and then 8.5. So okay, so it looks like this, and this is going to then be replaced with the actual persistent. So that was this one. So let's just change this here. This is returned. Okay, so we have that's printf, like we talked about. It's going to get the path to the launch agents. It's going to add the com.installation instructions to this side of the /, and then it's going to put the .plist at the end. So this is going to be path to plist, and that's a launch agent. And now we have, let me move this over so I can see better. So this function is going to get in this com.installation instructions in the full path. Okay, so this is going to build out the plist, and we can see that pretty quickly if we see that this is all stircats, and this was a screenshot that I shared yesterday. But for the sake of time, let's just look at this one really quickly, because this is like a really large string, and we can see what it returns. So this is 26, and this is 93. So save, run. This is going to be the start of this plist, which actually it'll be prettier if I go back and just add this as a comment here like I did in the screenshot. So this starts out all the parts of the plist, and if we go back, we'll see com.installation instructions. This com dot is the first argument, and then I forgot already what this was, full path. So these are then used and pass in where they're supposed to be in order to have this persistent item, which again is gonna create a launch agent for persistence. So we know this function sets up plist. So let's go back. This sets up plist and it's gonna return that huge blob. So plist contents. And we fopen the path to this plist, right? So that's already been set up. And here's a mode, which is going to be a write. We're not going to go into that right now. It's going to do a write. And if it doesn't exist, it's going to create it. So this fopen is going to create it. And this is a file handle to plist. And what it's going to do is going to do an fput. So it's going to move the the plist contents that was created and returned by this function, and it's going to then populate that plist. So this is going to set up our persistence. So we can rename this set up persist. All right, so that completes that part of it. And let's go to where this is called. Sets up persistence here. And now we go down to this while loop. So this while loop runs this function, which has a bunch of other stuff. But let's kind of go through this one quickly because there's some interesting things in here because we have an actual popen. So this is going to be like the mode that's passing the popen, but this will be the actual command. It's always the first argument. So we can see what command is executed here. And then we have, this is 5.9, so that's a pretty large string. And then this is 1C. So save, run. So this is going to be the ioreg command that's returned by this. So let's go back. So let's just paste that here. This is the command that's executed. So for behavioral detection, that'll be good if you're already monitoring for like ioreg stuff, you would see this. So that's here. So process. Oh. Process. And then we are just going to do that. Running out of time, but essentially this does another. This is only for one character, so we're not going to worry about that. It does the popen and it does a bunch of other stuff here using that. This is going to return like a UUID that it then uses later. So let's go into the network communication really quickly. And then we can kind of end this. So here, this is going to be another string that we're concerned with. So let's just grab this. And then it's going to be 2.5 and then 10. Save, run. And this is finally our C2. So this is going to return to C2. So let's just rename that C2 accept. So this is going to be the call. It's going to return that UUID. C2 is here, so we can put the C2 here. And just to see how this is passed in, let's just look to see where the C2 is passed. We have this null, so this is just some empty space. And then this return from here, which is that UUID that we'll talk about. And then this function is called. And we have that C2 as the first argument. So here we can see all of these are related to setting up that curl. And this is going to be the URL. This is going to be a write function that then is going to run this function. And it's going to then write that function and write the contents of this request to this argument here. because B is returned here as like where this is going to be written to. This equals file. So this is a file option. And then return bytes are here. R2. So R2 is going to be our return bytes. So that's going to then create that connection to C2. It's going to run this function here. It's going to return the byte here. And let's rename this to C2 comms. And then go back out. C2 comms. This is going to be return bytes is this. Return bytes. And if it's not 0, it does this. So let's see what it does here. File name with this function, going to create that file name, random file name. This ends up being an sh here, and then, no, this is an sh, and then it grabs this and it creates this like unique file name in the temp directory. And this is then, so temp file pointer, and then fputs, those return bytes are moved in here. So file to execute. So it actually writes the bytes to disk in the temp directory with the extension of .sh, which we can see pretty quickly here. So boom. Let's just do this last one because going a little long. 3 and then 9c run. So .sh is returned here. So .sh, and that's going to be the file path, like it's going to be a shell script or something that is returned. And we can confirm that because this fputs puts those bytes to here, and this temp file, so this still has a pointer to that temp file. We're then doing a chmod, and then what we're going to do is this fprint f is going to grab the contents of that and then run that with system, and then it's going to execute those bytes. So a lot of stuff. I know it kind of went quick there at the end, but just wanted to go through this one because it was pretty cool. And after it finishes that, it just goes back and it will continue running this, and it will sleep. So it will just reach back out, grab some bytes from C2, write them to disk, and execute. All right. Well, hopefully that was helpful for anyone that wants to dig into these things. This one was a pretty fun one. But yeah, having a script to help you with this stuff is like super important. All right. See y'all.